Okay, let's talk about oxidation numbers. There's one key to getting most of these problems down, and it's just remembering these 7-8 rules here. With these rules, most questions will be easy, or they at least will be something that you can figure out. So, just to go over them, group 1, always going to be +1. So that is on our periodic table, right? Group 1 is the first column. Always +1. Group 2, this one, this one, always going to be +2. So the farthest left column, always +1. The farthest right column, always +2. Next important rule is that halogens, especially fluorine, are -1. So halogens are fluorine, chlorine, bromide, iodine, and At, which is astatine, which you probably will not see, but most of the time halogens are -1. It's called group 7 also, or 17 if you're just counting the columns. It's number 17. There are some exceptions. Chlorine, bromide, iodine, they can be positive. They can be positive with oxygen, where fluorine is always going to be negative. Next, hydrogen, +1 with all non-metals. So that's essentially most things you'll run into in organic chemistry. Hydrogen is going to be -1 with the metal. So if you had something like H, hydrogen zinc, that would be a -1 hydrogen right there, but those aren't going to come up very much. Next, you have oxygen. Oxygen is going to be -2, which the only exception being that in peroxides you get -1, because you got +1, +1, -1, -1. The last important rule is that the sum of all the things added together is going to equal either 0 for a neutral compound, 0, or whatever the charge is of that ion. So anything with a +2 next to it or a -2 next to it at the end, that's oxidation state or oxidation numbers need to add up to that ion charge. So let's go through a couple examples, see if we can get some practice with these rules. First example we'll go through, easy, just CH4. I'll try to do mostly organic chemistry type examples, but let's look at our rule. Before we do this, one other rule, it's not really a rule, but carbon is flexible. So in this one here, what's our first rule? Hydrogen. Well, we know hydrogen, boom, +1 with non-metals. Carbon's a non-metal. So this here is going to be +1. We know there's 4 of them, so its total charge is going to be +4 for hydrogen. It's a neutral compound, so the sum must be 0. Last thing we got left, carbon, something +4 equals 0. Well, that's going to have to be -4. So carbon's oxidation number, -4, hydrogen, +1. Let's try another example. Let's let us do a super basic carbonyl. So the sum here is still 0. We know we've got some rules to follow. Hydrogen, we know that's a +1. Oxygen, we know that's a -2, -2, and +1 here. So we've got 2 positive, 4 negative. So far we've got -4, +2, and now carbon. So this here is going to equal -2, so carbon must be +2. You can see carbon is the flexible molecule. -4 here, +4 here. Let's do another one. Let's go. Let's see. Let's go with CH3OH. So what kind of rules do we got? Well, we know that hydrogen is a +1, so we've got +3. Oxygen is a -2. Hydrogen is a +1. We know our sum should be 0. So +1, +3 -2 is +1, +1 is 2. So carbon must be -2. So there's some carbon, oxygen, hydrogen examples. That's common OChem examples. Let's do a couple other ones just to practice some more rules. Let's go just some basic compounds. Let's try HCl. Let's go with O2, KMNO4, and let's just do salt. So what do we know right off the bat? We've got all uncharged. Hydrogen we know +1, well, chlorine's a halogen, so it's most likely -1, perfect. +1, -1. O2, now this rule I haven't gone over yet. An atom by itself is always 0. O2, 0. O3, 0. Na, 0. Iodine, 0. Anything that's just by itself in its elemental state, 0. Let's move on. We know that oxygen's -2, so this is a -8. We know K is a group 1 atom, so it must be a +1. Combined, it needs to equal 0. So here, +1 x -8, this must be +7. Last, NaCl, well, we got a halogen, so that's probably -1. And we've got sodium, which is a group 1, so that's got to be +1. +1, -1. Let's see if I can. What would be. Let's let's see. We need a good charged molecule. What? Let's do Cr O4 2 minus. Now Cr is a metal, it's chromium, oxygen, -2. So we know that this is 4 times -2, so this is -8, needs to equal -2, so chromium must be +6. So you can start to see how if you learn these rules, plus that atoms by themselves are 0, you can answer most oxidation state questions. Let's see if we can do just one more. Let's do a couple more actually that are charged. So we know here our final answer needs to be -2. We know oxygen here is going to be -8. Boom. Sulfur again, +6. Let's see, we have 3 oxygens. Well, that's -6. We need to equal -1. Hydrogen's a +1. Well, the difference there, +1, -6. This must mean that carbon is +4, leaving just 1 minus. I hope you enjoyed going through these oxidation rules. Just to review, group 1 +1, group 2 +2. Halogens, or group 17, are -1. They can be positive with oxygen, but fluorine is always -1. Oxygens can be -2, except in peroxides, where we get -1, and hydrogen is +1 with nonmetals, -1 with metals. Always sum things up to 0, or whatever the ion's charge is, and carbon is very flexible. Thanks for watching. Rover Star. Oh, what's that? See you later.